In today's lessons, we're going to solve trig equations without using a calculator. So if we can't use a calculator, that means we have to rely on our special triangles that we know. Whenever you're solving any equation, whether it's trig, linear, quadratic, it means that you're looking for your left side to be equal to your right side. So first we realize that with our solutions, we want all the angles between 0 and 360 degrees that make this statement true. So when is cos theta equal to 1/2? What is the angle? So when we solved our work before, theta equals 1/2, and then we take the inverse of that, doing the opposite on the other side in order for the cos to go away on the left side and isolate for theta. So we know that theta is equal to 60 degrees because of our special triangles. When cos has a ratio of 1/2, the angle is 60 degrees. Now, because of our range, our domain of 0 to 360, we have to be sure that we have them all. So 60 degrees is our angle there, 60 degrees. And remember our CAST principle, C-A-S-T. So that means that it is positive here, the ratio. So where else is that, where else could we produce an angle of 60 degrees with a positive ratio of 1/2? Cos is positive here. So if we were to draw a related acute angle in here, 60 degrees, then we have to calculate what the actual angle is, what theta actually is from there to there, from the initial to the terminal arm. So 360 degrees minus 60 is equal to 300. So our other angle that is true that fits within our domain of 0 to 360 is 300 degrees. So if you subbed 300 or 60 into cos and put it into your calculator, both times you'd get a ratio of 0.5. And feel free to test that out to be sure that you can see it for yourself. Let's look at another example here that is similar, but a little bit different. It's going to have the same domain from 0 to 360, but it now says 2 theta as opposed to just theta that equals 1/2. Now we don't quite know how to deal with this 2 theta yet when we need to isolate. So our first step is to just give it another symbol for an unknown. Cos alpha, that just means an unknown, is equal to 1/2. So if we have this right now, it's pretty easy to isolate. We know our special triangles, the inverse of 1/2, and alpha is equal to 60 degrees. We also know from our previous example, using related acute angles, that alpha at this point is equal to 300 degrees as well. But what we can't forget is we aren't actually solving for alpha. We're solving for 2 theta. So we bring that back now and solve for what theta actually is. So that alpha is just used temporarily to simplify our work. So what we have to do is divide both sides by 2, and we have the answer of 30 degrees. Same thing here. We don't actually want alpha. We wanted to bring that 2 theta back, equals 300. We divide both sides by 2, and our theta equals 150 degrees. Now what we need to check that now that we have the 30 and the 150, I'm first going to only worry about my 30 degrees. So we always have to be sure we have all of the angles between 0 and 360, or theta between 0 and 360 degrees. So there's my 30 for cos, and now I have to look to see for other places where the related acute angle is 30 degrees, because it'll get me the same ratio. So here it's 30. This is where cos has positive ratios. So now I need to check down here as well. 330 is also another solution. So theta can be equal to 330 degrees. Now I have to check for my 150 degrees here. 150 degrees from here to here gives me a related acute angle of 30 degrees. And here, cos is negative. That ratio is negative. Remember, C-A-S-T. So cos is also negative, the ratio down here. So if I have a related acute angle here of 30, it has an angle of 210 degrees all the way around. So another answer here is 210 degrees. So there's actually 4 solutions all in the domain that was given to you of 0 to 360 degrees. And you can check that in your calculator. Substitute in those angles into the original equation. Cos 2 times theta equals 1/2, and you'll see that your left side equals your right side. So whenever you're multiplying by theta, it's important to realize that you have them all. Now another trick that makes it a little bit easier too, if you don't want to do the sketches the whole way, is that if you have a domain, let's say that's from 0, theta 360 degrees, that's our original theta, but you have 2 theta that you're solving for, double your domain, 720. Those are the ones that you're checking for. So when you bring in your alpha, you can check at that point as well for 720 degrees. All right, let's do one more example to be sure that we're okay with the new concept. So for example, if we had 2 sine 2 times theta equals the square root of 3. Now we keep isolating for the theta. That's what our unknown is. That's what we're looking to solve. So I'm going to divide both sides by 2. So now I'm left with sine 2 theta equals the square root of 3 over 2. For simplicity, so I don't have to isolate for just theta yet, I'm going to call this alpha, and I'll worry about that 2 at the very end. So alpha sine inverse. Because of my special triangles, I know that alpha is equal to 60 degrees. I'm just going to put here that we do have a range of 0 to 360 degrees. Or, if I want, I can think of it as alpha, so I can do them all right away rather than at the end. So if I have 60 degrees, and that's a positive ratio, so when sine is 60, CAS, sine's also positive here, 60. So my angles so far is alpha is 60 degrees and 120 degrees, but I need to go up into 720, so I just add 360 to each of them. So 60 plus 360 equals 420, and then the same thing for our last one. 120 plus 360 equals 480 degrees. So when I bring back my 2 theta, I will have captured all of the degrees between 0 and 360 degrees. So theta here is 30. I bring back my 2 theta. Theta here is 60. Excuse me, 210 degrees. And last one, theta equals 240 degrees. So there's the 4 solutions that would make the left side equal the right side. For the beginning of class tomorrow, I'm going to leave you with 2 questions that are important to try. The first one being 2 cos theta equals negative square root of 2. The second one being 2 sine 3 theta plus 1 equals 0. Keeping in mind that these are all to be done without a calculator using your special triangles, and our next lesson will start the questions and the equations that we have to solve using your calculator.